topic is implicit differentiation. Implicit differentiation means calculating derivatives of an implicitly given function. So derivatives of implicitly given functions. So first thing, what is that? What are implicitly given functions? These are very special functions. Like there are regular functions, like for example, like f of x equals, I don't know, 3x squared minus 2x plus 1. So that's a regular kind of function. And then of course we can plug in any value for x. Say x equals 1. And then we get f of 1 equals 3 times 1 squared minus 2 times 1 plus 1. So 3 minus 2 is 1, plus 1 is 2, so 2 is the function value. Or it could be, instead of the function notation, f of x could be y, so it could be like this: y equals 3x squared minus 2x plus 1. And then again we can plug in x equals 1. And we get y equals 3 times 1 squared minus 2 times 1 plus 1, and again it equals 2. Now it's a y value because the function is denoted by y. So this is y value. Now these are regular functions and they are called explicitly given functions. So how could it be otherwise? How could it be other than that? So there are actually functions that are defined differently, and here is one example. So how could it be? So this original function was y equals 3x squared minus 2x plus 1. Here's another example. X squared minus y cubed equals 1. So what is that? It's also an equation involving x and y. Compare it with this one. This is also an equation involving x and y. And this equation also defines y as a function of x. Y as a function of x. However, in this equation y is not isolated, so this is not given as an explicit formula. This is an explicit formula for y. Explicit formula in the sense that y equals some formula involving x. Now this is an equation involving x and y, and it's not expressed in the form y equals something with x. However, it is still defined. This equation still defines a function, and we can do pretty much the same thing. For example, we can plug in, let's say x equals 3. So if we do plug in, it will be 3 squared minus y cubed equals 1, 9 minus y cubed equals 1, So isolate y cube equals negative 8, 1 minus 9 is negative 8, and so y equals negative 2. Y equals negative 2. So we can still find y value for this function, or the function value. However, it's not just plugging into a formula like here, it's rather solving an equation. So it takes some work to actually figure out the value of the function when you plug in x value. And functions like this are called implicitly given function. So this is called implicitly given function. As opposite to this, which is explicitly given function. Y equals, no, actually y equals positive 8 and y cube equals positive 8 and y equals positive 2. Anyway, this function is called implicitly given function. Now, how to calculate derivative of such a function? Like if a function given with an explicit formula, then we know all kinds of rules to calculate the derivative, such as the power rule, or more complicated formulas we will use product rule, quotient rule, chain rule. But if we go back to a function like this, so how can we calculate the derivative? So here's the question. Find the derivative. And since this function is since the letter y actually defines a function, so the proper notation for the derivative will be dy over dx. Or simpler notation, just y prime. So how can we find the derivative for such a function? Well, one thing we can do is to express this function as an explicit function, which means isolate y. Can try to isolate y. And what I mean is put it in the form y equals something. So in this case, it's actually quite simple. X squared minus y cubed equals 1. So first we isolate y cubed, and for that we put y cubed on this side and 1 on this side. So y cubed equals x squared minus 1. And now we isolate y by doing cube root of both sides. And we're done. So now it is an explicitly given function because y is isolated. So we're able to translate an implicitly given function with this equation into an explicitly given function. And now if we need the derivative, then of course we can apply any rules that we have studied about explicitly given functions. In this case we have to apply the chain rule. But unfortunately this method of trying to isolate y often is not working. So very often there are equations involving x and y in which y cannot be isolated, therefore you cannot put your equation in this form and you cannot apply any rules to calculate derivative. In such situations there is a special method that we can use to calculate derivative of such a function. So here's an example. X squared minus x cubed y plus y to the power 5 equals 10. This equation represents y as a function of x again, this equation defines or represents y as a function of x. And the question is find the derivative of this function. Again, the proper notation will be dy over dx, so find this derivative, or y prime. Now this equation cannot be solved in terms of y. We cannot isolate y because this is an equation of the fifth degree. So we should use other methods. And the idea of the other method is this. So the idea is this. Look at the left hand side and the right hand side of this equation. Left hand side and right hand side of this equation. So the idea is that left hand side is certain function of x, because y is a function of x and this is certain very complicated function of x. And the right hand side can also be considered function of x. And they are equal as functions because they equal for any x value, and since they are equal, their derivatives also equal. So left hand side derivative equals right hand side derivative. This method actually can be used in many situations. For example, we can use it to solve derivative of the natural logarithm, and in many other situations. Now this is another situation in which this trick actually works well. Let's start with the right hand side derivative. Right hand side is just 10. So it's a number, and derivative of a number is 0. So derivative of the right hand side is 0. Left hand side is more complicated. So let me write it here. Left hand side is x squared minus x cubed y and plus y to the power 5. Now to calculate derivative of the left hand side, we have to apply some rules. Like x squared is easy, so the derivative is just 2x. Now to calculate derivative of this, then minus means minus on the derivative. Now to calculate the derivative of this x cubed times y, we need to remember that y is actually a function, even though we don't know the formula for this function, but it is a function, and so we have a product of two functions, like x cubed times y, and because it's a product, so we have to use product rule. It's a product, and so we need to use product rule, and since there is a minus staying instead of in front of the product, so that same minus will stay in front of the product rule. Now how does product rule work? Derivative of x cubed will be 3x squared times y, and then plus, now x cubed times, and then we need derivative of y. And derivative of y is just y prime, so times y prime. So this is my product rule here. Product rule. And then plus, and then we need to calculate derivative of y to the fifth degree. Again, remember that y is actually a function, and function in the fifth degree is actually something inside something else, where we need to apply the chain rule. So you can think of it like, for example, if it were, let's say that we know that the formula for y, for example, x squared plus 3x plus 1 to the power 5. Derivative of that would be, by using the chain rule, we have to use chain rule for this, and the derivative will be 5 times x squared plus 3x plus 1 to the power 4, and then times derivative of the inside, which is 2x plus 3. Now here, we will be using the same idea, except the interior part is just y, and the derivative of y is unknown. But even though it's unknown, we can just use y prime for that. So we can do derivative of y to the fifth the following way: 5y to the power 4, which is derivative of the exterior function, and then times, and the derivative of the interior function. Again, since the interior function is just y, the derivative of that is just y prime. So this is the derivative of y to the fifth. using the chain rule. Now once again, the chain rule in this context is pretty simple. Like you do derivative normal way, like y to the fifth becomes 5y to the power 4, and then you multiply it times y prime. Because again, y is the interior part and the derivative of y is y prime. So the shortcut is this: whenever you do derivative of either left hand side or right hand side and you need to do derivative of something involving y, you treat y as a function, which means you do derivative normal way and then multiply times y prime. Once again, whenever you do derivative of any expression involving y, like y to the fifth, then you do derivative normal way, like 5y to the fourth, but then multiply times y prime. So that's the chain rule, how we use chain rule in the context of implicitly given functions. So this is the left hand side derivative. That's the left hand side derivative. And now left hand side derivative equals the right hand side derivative. And right hand side derivative we already calculated, it's 0. So it equals 0, because 0 is right hand side derivative. So now what we got here, we got an equation involving x, y and y prime. So let me copy this equation. So starting with equation involving only x and y and using this method, left hand side derivative equals right hand side derivative, we've got the following. We've got 2x minus, and now I want to distribute this minus, so minus 3x squared y, and minus distribute, so this one becomes minus as well, minus x cubed y prime, and plus 5y to the fourth y prime. That was the derivative of the left hand side, equals derivative of the right hand side is just 0. So we've got an equation involving x, y, and y prime. And the idea, and remember that we need to find y prime. And we'll treat x and y as known and y prime as unknown. And y prime will always be in the first degree. It will never be y prime squared or something else, so it will be always first degree, like something times y prime. And in this context, solving for y prime is very easy. We want to keep all the terms involving y prime on one side of the equation, and all the terms not involving y prime, like this term and this term, we want to take it to the other side of the equation. And when we take a term to the other side of the equation, positive term becomes negative and negative term becomes positive. So here's what it becomes. It becomes minus x cubed y prime plus 5y to the fourth y prime. And there are no more terms with y prime, so we keep these two terms on the left hand side of the equation. The other two terms that have no y prime in it, we put on the right hand side of the equation, and this one becomes negative 2x. This one was negative, so it becomes positive 3x squared y. Now we can factor out y prime minus x cubed minus x cubed plus 5 times y to the fourth. Right hand side is the same, so 2 minus 2x plus 3x squared y. And finally we just isolate y prime by dividing both sides over this factor of y prime, and what it becomes y prime equals this over that, so minus 2x plus 3x squared y divided minus x cubed minus plus 5y to the fourth. So that's it. I have found expression for the derivative of that function. Of course this expression involves both x and y, but still we found that expression. In fact, this method is kind of miraculous because we were not able to find expression for y. It was not able to solve the original equation for y, but it is possible to solve it for y prime. And once again, this method is called implicit differentiation.